say? I'm not
I feel like he'd be better off just to go back and look it up.
telling you.
All right, definite integrals and antiderivatives. And obviously we have a mean value theorem for definite integrals as well. You saw that in the notes, I'm sure. So, and these are all basically just using the theorems and stuff, or not the theorems, the little formulas and stuff that we had. So this says, the exercises in this section are designed to reinforce your understanding of the definite integral from the algebraic and geometric points of view. For this reason, you should not use the numerical integration capability of your calculator. Yes.
Did not catch any of what she just said.
No, but I saw them going into Mrs. Patton's room. I think they both had a quiz to make up, or a test, so that might be where they are. Uh-huh. Bye.
So if we don't have school tomorrow, then what are we doing about that tennis?
We'll just reschedule it for when we do have school.
Okie dokie.
Did I tell you?
It's really just for me to see how many people we have. So if I know for like 100% fact like who's doing it, like I don't really need to have a meeting, but
Okay, doke.
I ran my first mile in a while was it yesterday? I don't know. I texted Josh about it.
you went on a cold day and not the warm day on Sunday.
It was on a treadmill. I was not going outside.
Oh.
I almost
I
flew
ran.
off though. I tripped like twice in a row over my foot, and I was like looking around to see if anyone saw. I was like,
I ran 4 miles on Sunday on the treadmill.
I don't like doing it on a treadmill.
We walked 2 miles on Sunday.
Hey, was it outside?
Yeah.
I was so confused on that first integral there. I couldn't tell if that was supposed to be an A, a Q. Then I finally settled on 9.
I looked up and there was so much up
So that is the number 9, right?
Yes.
Not Q.
Yes. So basically, they give us different things, and we're supposed to use the integral rules to, like, solve these. So all those, like, the sum and differences, constant multiple, all that stuff, we're using those to do these.
Why does it randomly switch to H of X?
There's probably a reason for that.
Yeah, because it's, like, two different, because it's from the same thing. So it'll be when we're doing, like, adding and stuff. All right, so the first one is the integral from 1 to 9 of negative 2 f of x dx. So let me pull these so that I know which the actual rule is. Constant multiple rule says that if we have a number inside, we can like take it out and put it out front because nothing's changing to a constant. So this would be negative 2 times the integral from 1 to 9 of f of x dx. And then we're told that the integral from 1 to 9 of f of x dx is equal to negative 1 from what we were given. So this ends up being negative 2 times negative 1, which is 2. So that's equal to 2. B is the integral from 7 to 9 of f of x plus h of x dx. So this is the integral from 7 to 9 of f of x dx plus the integral from 7 to 9 of h of x dx. And we know what both of those things are equal to, so that's just 5 plus 4, which equals 9. And you don't necessarily have to write this stuff like all out when you do this. I'm just doing it while we're
For reference.
using it and for reference. So C, the integral from 7 to 9 of 2f of x plus 3, no, not 3 plus, minus 3h of x dx. So this one is having two things happening to it. So it's the two things being added together. And then within that, both things have something that they're also being multiplied by. So in one step, I'm going to do 2, and then the integral from 7 to 9 of f of x dx minus 3 integral from 7 to 9 h of x dx, which that ends up being 2 times 5 minus 3 times 4, which is negative 2.
I'm afraid to say that these are making sense.
This stuff, it should be. It shouldn't be something that's confusing.
Okay, so it's not gonna get super scary hard.
I mean, if you understand antiderivatives, it's not. D, the integral from 9 to 1 of f of x dx. Let's see if y'all can tell me what rule you think I need here.
That's the integration.
Yep, because I was given what it is from 1 to 9, and if this is from 9 to 1, that means I need to flip it, which implies that I need to take a negative out. So this is negative integral from 1 to 9 of f of x dx. So that ends up being negative times negative 1, which is just 1. All right, this next one you may not have, I don't necessarily think there's a specific, well, there kind of is, but it's a different modification of it, is from 1 to 7 of f of x dx. So do I have something that I was given that's just 1 to 7? No. But I do have 1 to 9, and I also have 7 to 9. So if you look at the additivity rule that you had, it's a modification of that. So that one was integral from a to b, and the integral from b to c, and that's equal to the integral from a to c. So essentially, this is a similar thing, except for it's subtracting.
So like we
So
go
it's-
from like A to, like I guess.
It would be like a to c minus b to c
Okay.
would give us the 1 to 7. Yeah. So in this case, this is going to be the integral from 1 to 9 of f of x dx minus the integral from 7 to 9 of f of x dx, which is negative 1 minus 5 or negative 6. Then f, the integral from 9 to 7 of h of x minus f of x dx. What do you think I might need to do with this one?
The order thing.
The order, and also obviously they're being subtracted. So this would be negative integral from 7 to 9 of h of x dx. And then it would be minus a negative, so that's going to be plus. I'll write this here as minus negative. The integral from 7 to 9 of f of x dx, which would be negative 4 plus 5, which is 1.
How do you feel about people doing that?
Okay, this one says show that the value of the integral from 0 to 1 of the square root of x plus 8 dx lies between 2 root 2 and 3. So, what radical is 2 root 2?
8.
Yep. So this would be the same thing as the square root of 8. And what about 3?
9.
Yeah, square root of 9. So this is the what is this one? Does this one specifically have a name? This one may not have a name. Okay, anyways. So basically what I'm going to do is I'm showing that this is between these two things. So I'm going to have the integral from 0 to 1 of the square root of 8 dx is less than or equal to the integral from 0 to 1 of the square root of x plus 8 dx is less than or equal to the integral from 0 to 1 of the square root of 9 dx. And so 2 root 2 is less than or equal to the integral from 0 to 1 of the square root of x plus 8 dx, less than or equal to 3. And I showed it.
That's it.
Yep. It's kind of a combination of the, well, it's kind of like the domination one, but it's also the max-min inequality. Like, it's predominantly the max-min inequality, but it's kind of like the domination a little bit and how it's like set up, but it's predominantly max-min.
I feel like they probably won't be putting problems like that on the AP exam because
Probably not, but
seems too easy.
could be a multiple choice though, you never know.
Is like the middle step required? Like that's the main part of the work in that?
This is like showing it, yeah.
Okay.
Like showing the setup, and then this is like the final. So. All right, next one says, it says to use NINT, but we are not going to do that because
And
we can do it by hand. So we're going to do it by hand. So we've got 12. Y equals negative x squared over 2 from 0 to 3. And this is an average value problem. So the average value, which this is in your notes, is equal to 1 over b minus a times the integral from a to b of f of x dx. So this would be 1 over 3 minus 0 times the integral from 0 to 3 of negative x squared over 2 dx. And a lot of times I go ahead and take this negative and I put it out front, and sometimes, because you can also do this with like just like a constant number, I'll go ahead and pull the 2 out as well. Like the, well, let me rephrase, the 1/2 out, but I'm just going to leave it for right now. So this would be negative 1/3 integral from 0 to 3 of x squared over 2 dx, and now I need to take the antiderivative of this, which would be what? What's the power have to be? So what does this need to be multiplied by so that when I take the derivative, I end up with 1/2?
I'm gonna say 1/6.
So 1/6 x cubed evaluated from 0 to 3. And I can actually take this 1/6 and put it out front with that, right? So this is going to be -1/18 times 3 cubed minus 0 cubed, which is just -27/18, which reduces to -3/2. So it also says at what point or points in the interval does the function assume its average value? So this is y. So I need to plug that in up here and solve for x and see where it actually occurs in this interval. So we would have -3/2 equals -x²/2. So if I multiply by -2, I get 3 is equal to x². So x equals the square root of 3. Obviously, normally it's plus or minus, but it has to be in the interval, and the interval is 0 to 3. So that's why it's just the positive one. So this, technically, the way that the book writes the answer is it's -3/2 at x equals the square root of 3. All right, the next problems are going to require our thinking caps.
Gosh, I don't know where I left that.
I don't have one.
Hope you can find it. Better run to the store. Interpret the integrand as the rate of change of a quantity and evaluate the integral using the antiderivative of the quantity. No NINT.
I just thought it'd be a good time to get it out. You know, just in case.
Trying to cheat over there.
You won't
Shut
need
up.
it. The integral from 0 to pi/2 of the cosine of x dx. So anytime we have something like this, where it's not just like an x to some power or a string of x's raised to some power, whatever, I have, obviously if I'm dealing with trig functions, if I'm dealing with logs or whatever, I'm thinking the derivative of what is cosine in this particular case.
Negative sign.
Sign.
Outside.
Not the derivative of this, the derivative of what gives me cosine.
Yeah.
So it would be sine. So this would be the sine of x evaluated from 0 to pi/2. So we've got the sine of pi/2 minus the sine of 0, which would be what?
Square root of 2. No. Oh,
What?
sine of 0. Wait, hold on.
1. Because this is 1 minus 0.
I just had to unit circle
I
it.
don't know why.
It's
I
like
saw
we might
2.
need that unit circle quiz after all.
I saw 2 and I actually thought of what's it called?
Cosine?
That'd be pi/4, son.
Well, it's too early.
It's 1 o'clock. See gets 1.
It's actually 101.
Well, the microwave says it's
Like
1.
Zoe.
Oh,
All right.
What? Where?
So we went on one school. I was like, that'd be so fun.
The integral from 0 to pi over 4 of secant squared of x dx. So as I think about this, the derivative of what is secant squared?
I just said that.
Tangent. I didn't want to steal your answer.
The tangent of x evaluated from 0 to pi over 4 is the tangent of pi over 4 minus the tangent of 0. Which is what?
1. Yes.
Yep. (24) The integral from -1 to 2 of 3x squared dx. So not a trig function, so I'm just taking the antiderivative naturally.
You got this one, Virginia.
Oh. X cubed.
Yep, x cubed evaluated from -1 to 2. So this would be 2 cubed minus -1 cubed.
Still got this, Virginia.
Oh, no. 7. I mean 9. I mean 9. I take it back. I mean 9.
She was so confident. 7. I mean 9.
I was trying to work out my thing. If you would have given me like 10 more seconds, I would
Oh, I
have.
already had it all worked out before you
Well-
even said the derivative, antiderivative, Virginia.
Well, I actually got that pretty quick this time. That usually takes me the longest.
26. The integral from 3 to 7 of 8 dx.
I'm too scared to answer.
It's not 7.
I keep that in mind.
Josh?
8x.
Oh. She got this
I'm
one.
stealing.
8x evaluated from 3 to 7. So I've got
32.
God, stop that. 8 times 7 minus 8 times 3 is 32. I'm gonna get a little harder. 28. The integral from 0 to 1/2 of 1 over the square root of 1 minus x squared dx.
Oh, that's a
Inverse sine.
What do you think, Virginia? Is he right or is he wrong?
I couldn't tell
I
you.
agree with him. I think.
Good choice.
Yay.
So this is the inverse sine of x evaluated from 0 to 1/2. So this is the inverse sine of 1/2. Let's see if you remember what that means. Minus the inverse sine of 0. Let's do it this way. What's the inverse sine of 1/2?
Pi over 6.
Pi over 6. And what's the inverse sine of 0?
Pi over 0. 3 pi over.
When the y is 0, yeah, 0. So that's just pi over 6.
How do we do the inverse or like the
So the inverse sign is when we have the x or y value. So like in this case it was y. So when y was equal to 1/2, an inverse sign can only occur on the right side. Inverse cosine only occurs on the top. And inverse tangent is also only on the side, the right side. But it's also only from negative pi over 2 to pi over 2.
okay.
So this one was pi over 6. All right. Don't normally do this, but we're doing an odd one. The integral from 1 to e of 1 over x dx. So the derivative of what is 1 over x?
ln of x.
ln of x evaluated from 1 to e is the ln of e minus the ln of 1. So what does that equal to?
You got this, Virginia.
I don't think I do.
What's the ln of e?
I'm scared to answer.
This one should be really obvious. If you think
I
about
have-
it or don't.
Is it
E to the what equals e?
Did you say
1?
1. And e to the what equals 1?
0.
So this would be 1 minus 0, which is just 1.
Now, I'm not gonna lie, I did put e at first for ln of e. But then I realized that it can't just be e.
30, the integral from 1 to 4 of negative x squared, nope, negative x, hold please, negative x to the negative 2. I was glitching.
I do that all the time.
It's to the negative 1. Is it just
So what has to be in front that when I take the derivative I get a negative?
No.
nothing?
Okay. So from 1 to 4, so I've got, I don't know why I was going to write x to the negative 4. 4 to the negative 1 minus 1 to the negative 1. So this would be 1/4 minus 4 over 4 is negative 3 over 4. Helping us out with our fractions.
Did I have to write the 1 as 4 over 4, or does it just work that I wrote it as 1?
That's fine. I just did it so that we could visually see the common denominator.
It's more for those who might be watching in future years.
Or in a couple days.
Oh, no, I was thinking
It's for me.
All right. Find the average value of the function on the interval using antiderivatives to compute the integral.
Are we out of that section of those easy ones?
Yes.
Okay.
We only have 2 problems left.
Are we still doing 6.4 in physics?
Probably. It's up to y'all.
I'd rather do that.
Oh, did you take notes?
No, not yet.
I didn't. Will that be problematic?
I don't know. I need to look at it and see.
Problematic.
I promise.
Or when we finish this, because we're going to be done with this in like 5 minutes, you might could write write them all. I'll look and see. 32. Y equals 1 over x on the interval from e to 2e. So this is the average value. So it's 1 over b minus a. So 1 over 2e minus e times the integral from e to 2e of whatever our function is, so 1 over x dx. So this is 1 over e, and then what is the antiderivative of 1 over x?
You got this one, Virginia. You did it earlier.
ln of x.
ln of x evaluated from e to 2e. So it's 1 over e times the ln of 2e minus the ln of e. See if you remember properties of logs.
Of course I don't.
Does a log of a product equal to the sum of the logs sound familiar to anybody?
It sounds
Yes, but I
familiar,
don't
still know
remember what
it
you
means.
said.
So,
What did you say though?
log of a product is equal to the sum of the logs.
Yeah, that did not stick.
So the ln of 2 times e would be the ln of 2 plus the ln of e minus the ln of e. Now what happens?
It's just ln of
Yep, so I end up with the ln of 2 all over the e that's being multiplied outside. So that is the average value.
Wait, so how did you get that middle, like the plus ln of e minus ln of
The log of a product is equal to the sum of the logs.
That's
I
actually
also could have done instead here, I could have done the log of a quotient is equal to the difference of logs, and I could have written this as what's inside as the ln of 2e over e, and then the e's would have canceled and I would have been left with the ln of 2. So this is if I did the difference of logs is the log of a quotient. This is using the log of a product is the sum of the logs. All right, one more.
I love how the water from that balloon is still there.
Yeah, I haven't dumped it yet. 36. Y equals the secant of x times the tangent of x from 0 to pi over 3. So this is still average value. So I have 1 over pi over 3 minus 0 times the integral from 0 to pi over 3 of secant of x tangent of x dx. So essentially this just ends up being 3 over pi times derivative of what is secant of x tangent of x. I think y'all should say it at the same time. I'm not convinced Josh knows.
Wait, I didn't think about it.
1. Secant of x.
I wasn't ready.
I gave you a countdown, Virginia.
Yeah, but I wasn't ready.
Secant of x evaluated from 0 to pi over 3.
I knew it sounded familiar.
Familiar.
So 3 over pi times the secant of pi over 3 minus the secant of 0.
Oh, wait, secant of pi.
What's the cosine of pi over 3?
I know this. Wait. What goes with the? I know what one of them is. I just don't know. Is it 1/2?
Well, that's the cosine of pi over 3. So what would secant be?
2.
And what's the secant of 0?
1.
So this just ends up being 3 over pi. Nice and easy. Light work.
I don't know about that.
Seems pretty heavy to me.
You got like all of them right.
Now, I would say for extra practice, all odd from 19 to 27 would be beneficial to look at to make sure that you know what you're doing, but totally up to you if you want to do them all or not. Because we already did 29, so that's why it skips that one.